So what I want to do is I want to show you how we need to protect sensitive components when we're doing torch work. In our field we do a lot of torch work and we heat up a lot of copper, and a lot of times there's things attached to that copper that can't be overheated. And some examples of that would be a dryer, a liquid line dryer with a sight glass assembly. I can't overheat the dryer when I make this connection, and I can't overheat the sight glass when I make the connections on both sides. So I have to be mindful of that. Also, we have a lot of expansion valves that we're connecting and we're brazing on either end. We also have the expansion valve bulbs that will be connected to suction lines such as this 3/4 inch line I have here. If I was trying to protect this bulb, I should unhook it and I should take it away while I'm doing the brazing. Sometimes that's not possible, or it's a different component. So we need to do our best job to keep the heat from getting past the area we're working in. It might be the inside of the evaporator coil leading into the unit, or a service valve, or any number of things. Very commonly it's a dryer, and we don't want to burn the paint off, as well as we don't want to hurt the components inside. So we're going to cover this, we're going to protect it. And I'm going to show you one way to do that. I use wet, damp cloths, rags, paper towels, usually paper towels because I can throw them away. If you notice, these are damp. They're not dripping, they're not, putting water all over the place, but they're damp. And if I'm going to braze this connection and I'm wanting to protect this end, then I'm going to wrap it over here somewhere not so close to my connection to where it makes it hard to braze, but close enough to where it gets the job done. So I'm going to take this damp rag and I'm going to wrap it right here around the copper. And when the copper's bigger, like this, 3/4 versus say 3/8, if you don't have enough of the damp, cool rag on there, they'll overheat, they'll actually dry out before you get done. So I'm just going to wrap it around. I'm making sure it's in contact with the pipe, because if it's not touching the pipe, it's not going to take the heat out of the pipe. So now I'm going to make this connection here, and then we'll see the difference between the temperature on this end and the temperature on this end, how much blocking effect we have with our rag. So I always want to make sure we got our safety glasses on. I've already got my torch rig ready to go. We're going to give it a try here. Now, one other thing is, the longer it takes me to do this connection, the harder it is going to stop the heat. So I need to get it done as quick as I can and still make it good. So I'm going to adjust my heat accordingly. It's going to afford me to heat that up a lot faster. Something like that would be a good start. And I'll do the side closest to where I'm trying to protect first. Okay, so this one's been completely done all the way around. I even took the time to cap it off, which I always like to do. It's quite hot on this side. I can take a laser and I can check right in this area, and it's way up there, 150, 160 degrees, and getting hotter as we go. Right on the side of the braze, it's 500 something degrees. Over here on this side, past the rag, it's still cool. Right here, not hot, just barely warm. I'm not going to touch it on this side, but I can hold this. If this was an expansion valve bulb, the rag's doing the job, it's protecting this end, and look, it's only like 6 inches away. So the point is, it doesn't take a lot of water. My next step would be, I would take those same cool rags, and I would come back in and I would just continue to cool that joint down. But I haven't dripped any water anywhere. I haven't got water inside my piping, but I've accomplished my goal, which was to protect this side right here. So use the rags and use them sparingly like I did, and you'll have the same results.